Hi! In this lesson I'm going to talk about the modern periodic table. Okay, we all heard about the periodic table, and we all know that chemists they need the periodic table to know the characteristics of the elements and how they will tend to react and how they what's called how can you use them in forming new chemicals. Okay, so of course chemists need them. That's why they have the periodic table with them or they memorize it. Okay, now in the periodic table we can tell that there's those weird symbols in every box and numbers. What are they? An example here is acetone, AT. This symbol usually comes in one letter or two letters. Now most of the symbols or chemical symbols aren't in English or they're not English symbols. And we're going to talk about the symbols in another video because we have a video about chemical symbols. Okay, and then we have the atomic mass and the atomic number. Well, the atomic number, what is it? Well, the atomic number, when you look at the periodic table, it's usually always above the chemical symbol. What about the atomic mass? It's the number that is under the chemical symbol. Now, of course, in the periodic table, they give you under the chemical symbol the name of the element. Okay, so what is the atomic number? Well, the atomic number is first thing is you can say that it's like the ID card of the element. Without it, you won't know the element. Okay, so why is it like the ID card? Well, it's because it defines the number of protons in an element and also the electrons. Because we know that the number of protons, if it changes, then the element changes. So the same thing, it's like the ID of that element. And we all know that whenever we have 85 protons, then we have the element acetone. Okay. What about the atomic mass? Well, the atomic mass is just adding the number of protons and neutrons to get the mass of that element. Okay. So that's for the boxes inside the periodic table. Now let's talk about the periodic table itself. Of course, it was created by the scientist Dmitry Mendeleev, and he created the periodic table. That's the important idea. Now let's go back to the periodic table, but how is it how is it placed together? Okay. So in the periodic table, columns are usually defined as groups. So that's a column. It's defined as a group. That's group 1, 2, 3, 4, until 18. Then we have the periods, the rows. That's a row, that's a row, that's a row. Now periods, they differentiate in what? In the number of elements inside them. So in a row you can have 32 elements, or you can have 2 elements. We have 2 elements, or you can have 32. From francium, radium, then you continue from actinium till the last element. Then you continue from here till what? Oganesson. Okay, so this is how you get the 32 elements. Now in a group, usually it's 7 or 6, or you can have 4. Okay, so that's for the group. Usually in a periodic table, the group isn't numbered, doesn't have a number, so you won't see, like, for example, above the periodic table it's written 1 or 2. Some of them they don't, but this periodic table it does have. Now of course we said that in a group or in the similar group we have always the elements, they have what? Similar chemical and physical properties, and the closer the elements are to each other, they're going to have almost similar properties. So you can say that francium and cesium have almost the same properties, but if we say francium and lithium, they have a little bit of difference of properties because they're a little bit far from each other, but the closer they get, the closer they have, the closer their characteristics get. Okay, so this is all about our lesson for today. We're just talking about the periodic table and about what does it look like. But in the next lesson, I'm going to talk about protons, neutrons, and electrons, and how to calculate the number of protons in an element, and also about the chemical symbols, and also about to calculate the number of neutrons and electrons. So that's all about our lesson for today, and I hope it is useful.